Hi, so for today we are going to talk about radicals. This is a part of our study in algebra, and this is still we are continuing our videos in algebra for this year, and hopefully we can finish this subject. We are going back to basics so that when we jump into our calculus classes, we will be prepared. So for today, we are going to talk about radicals, and for example, in this what we are seeing right now is an example of a radical to exponential conversion. So where n is any positive integer, this n, that is greater than 1, and a is a real number. So we can read this as the nth square root of a equals a raised to 1 all over n. So basically, okay, um, we call this radical form to exponential form. So this is radical form and this is exponential. So we can always rewrite a radical form into exponential. Now we also have what we call n as the index, and we have a as the radicand. Okay, whatever is inside the radical sign, and this sign is what we call the radical sign. Okay, so we can always convert radical into exponential. So there is an exception if n equals 2 or the index equals 2. We have this one. We can simply rewrite this as simply the a, or this is the square root of a. Okay. So meaning, even if we don't write the number 2 here, it's considered that the index here is 2. Okay? So that's the square root. Now, let's try to solve some problems or try to write each of the following radical form or radicals into exponential form or exponent form. So first on our list is we have the fourth root of 16. So how do we do this? Again, um, from what we have seen a while ago, we have n root of a equals a raised to 1 all over n. This one is actually the exponent of whatever is inside the radical. So if we're going to convert this root fourth root of 16 into exponent form, so our n is 4 and the exponent of 16 is of course 1. So we have 16 raised to 1/4, of which this is our index and 1 is the exponent of whatever is inside the radical or the radical. So letter B, we have this 10th root of 8x. So it's very simple. We have 8x raised to 1 all over 10. Okay? So letter C, we have the square root of x squared plus y squared. So take note that this x squared and y squared is inside the radical sign. So they are together inside the radical sign. So this must be x squared plus y squared raised to 1/2. Okay? So that is how we are going to um, rewrite or convert a radical into exponential. Okay? So now, how are we going to simplify radicals now? Okay? So we have several properties of radicals. Properties of radicals. So for number 1, we have this one is simply equal to a. And the nth root of a raised to n is simply equal to a. The proof of that is that if we are going to convert this into exponential, this would be a raised to n, because this is raised to n, all over n. N all over n is simply a raised to 1, and a raised to 1 is simply a. so that we get this property. Okay? So that is property number 1. Number 2, when we are dealing with radicals, we have the nth root of AB, A multiplied by B, wherein A is another real number and B is another real number. We can actually separate them like this. Okay? So this is different from this, wherein this is actually addition. Okay? This is much more similar to this. So for number 3, we have, if we have a division of the nth root, A all over B, we can separate them as nth root of A all over nth root of B. So that's the property that we are going to take note of when we are dealing with the radicals. And also take note, while we can break up the products, okay, the products and the quotients, we can break it up. We cannot break up those radicands that has addition and subtraction. Note, let's say, if we have an example like this, the nth root of A plus B, that is not equal to the nth root of A plus nth root of B. That is not equal. The same as this. If we have A minus B, that is not equal. That cannot be written, in other words, into n root of A minus nth root of B. It cannot be. Only the products and the division or the quotient itself, we can break it up. Okay? But if we are going to have addition and subtraction, we cannot use the property like that. Okay? So let's try to assume. Okay? Or let's try to simplify radicals. So simplifying radicals. You know, in algebra, this is the most uh, used topic or the most discussed topic when we try to simplify radicals. So for example, we have the square root of y raised to 7. So how are we going to simplify this type of radical? Now, if you're going to identify the index here or the n equals 2, we know that even if we don't write 2 there, there is still a square root there. There is still a 2 there. So this is a square root of y raised to 7. The rule is, because the exponent of the radicand 7 is greater than the index, we can still simplify it. If the exponent of the radicand y raised to 7 is greater than the index, we can still simplify it. Okay, so if we are going to take a look at this, we can rewrite y raised to 7. If I'm going to write y raised to 7, that would be y raised to 6 multiplied by y. By laws of exponent, if we multiply y raised to 6 times y raised to 1, or simply y, that's equal to y raised to 7. We add up the exponent. But definitely, we can also rewrite y raised to 6 as this. We can rewrite it as y cubed squared. That is still equivalent to y raised to 6. Okay? And of course, don't forget to multiply it by y, since this is still y raised to 7. So why are we doing that? That is because we need that form of exponential to simplify it on the radical. So if we are going to have square root of y cubed squared multiplied by y, this is still y raised to 7. We can use the property of the products that we have a while ago. In that, if we have the nth root of AB, we can simply separate them individually. So I can separate this one, and this one. So I can separate it. I will be having square root of y cubed squared multiplied by the square root of y. Okay. And if we are going to convert this first term into exponential form, what would be the result? Our index is 2. So I have what? I have here y cubed, y cubed squared, okay? And then, since this is raised to square, this would be y all over 2. 2 all, y cubed 2 all over 2. Okay, how did that happen? Of course, again, we have y cubed raised to 2. That is our exponent. Okay? And that is actually multiplied. Okay? Or whatever is the index, that would be the denominator. Since my exponent here is 2, and my index here is 2, that would be 2 all over 2. In that case, that would be 1. Oh, and then multiplied by square root of y. So, y cubed multiplied by the square root of y, or simply y cubed square root of y. And that must be my final answer. Okay? So that will be my final answer. So again, we only use the exponential form in order to simplify our radicals. So for letter B, we have ninth root of x raised to 6. So the problem here is that we have an exponent inside the radicand that is less than the index. So it's okay. But what's wrong here is that if we are going to convert this into exponential, we'll be having this. X raised to 6, of course, and raised to 1 all over 9. Considering that we have an exponent of 1 here. Or you can simply rewrite this as x, okay, raised to 6 all over 9. No problem with that. Okay? So either this or this, no problem. If this one is your choice, since you group this x raised to 6 into an exponent of 1, you still multiply 6 times 1 raised to 9. 1 all over 9. So that becomes x raised to 6 all over 9. And this is x raised to 6 all over 9. We can simplify this. We know that this is x raised to 2/3. Okay? The same. So now, if we are going to rewrite this back into radicand form or the radical form, this 2 is the exponent of whatever is inside the radicand. Okay? And this 3 is actually what? The index. So this would be the cube root, the index of x squared. So that is furthermore simplified. Okay? So letter C, we have the square root of 18 x raised to 6 y raised to 11. So what are we going to do here is we have several violations here, okay, to simplify the radicand. So first of all, the exponent inside the radicand or the radical signs are greater than the index, which is 2. So we can simplify this, no doubt about it. So the thing here is that since our index is 2, okay, so we will be splitting these three terms, 18, x raised to 6, y raised to 11, in such a way that we can somehow simplify it or factor out some x and y and some factors of 18 outside of the square root sign. So how are we going to do it? So first of all, I have to, 9 is a perfect square. Okay, 3 squared is 9. So multiplied by 2, this is my 18. Okay? And of course, for the second term, which is x raised to 6, since this is a square, I'm going to have a factor wherein I can rewrite this x raised to 6 into somewhat I have 2 here. Okay? So that I can easily factor this x raised to n squared outside of the square root sign. Now, the problem is, what is this number n? Since this is 6, this must be cubed. X cubed squared. So that must be x cubed squared. So that if I'm going to simplify x cubed squared, x cubed times x cubed, that must be x raised to 6. Okay? So no problem because you can easily factor x cubed outside of the square root sign because they have the same index. Okay? So now, how about the y raised to 11? So I'm going to isolate one y here. Why? Because this 11 is an odd number. Okay? So our index is 2. That's an even. So I have y raised to 10. Okay? And this y raised to 10, I'm going to have to rewrite it into someone such a way that this exponent should be 2. And what number of n would make the equation y raised to 10 true? That is y raised to 5. So if I'm going to rewrite this y raised to 5 squared, y raised to 5 squared is y raised to 10. Okay, we multiply the exponent when it is raised. We add when it is multiplied. So since this is raised, 5 times 2 is y raised to 10. Then multiplied by y. So I'm going to rewrite this. This is simply equal to y raised to 11. I'm going to rewrite this as y raised to 5 squared multiplied by y. Okay? So again, using the properties of radicals, we can easily get the square root of some of the factors inside the radical. So we have 9. That's a perfect square. That's 3. And we can factor this out. We can simplify it. And this also we can simplify. So we have now the square root of 9. I'm going to rewrite it. Then multiplied by, I'm going to put 2 here. 2 times y here. Because those are not perfect square. We cannot evaluate them. We have square root of the x cubed squared multiplied by the square root of y raised to 5 squared multiplied by the square root of 2 times y. Okay? So the square root of 9 is 3. We always consider the square root, the positive square root of the positive number square root of 9, which is 3. Although we know that negative 3 is also a root. But in this case, we are going to consider the positive 1. So the square root of 9 is 3. And this simply cancels out. Okay? So we can factor out x cubed outside. Why again? Because x cubed raised to 2, okay, multiplied by 1/2, which is the square root. So that must be x cubed 2 all over 2. That's cancelled. So we have x cubed raised to 1, which is x cubed. The same goes with this one. That is y raised to 5. And then we have square root of 2y. And that's the simplified form of this radical right now. Okay? That's a simplified form for our radical in our example. Alright, for problem D, we have the fourth root of 32 x raised to 9, y raised to 5, and then z raised to 12. So these are all, the exponents of x, y, and z is greater than the index, which is 4. So this can be simplified. Okay? Yeah. So what are we going to do is the same thing that we did a while ago. So that must be fourth root. I'm going to split up 32 by 16 times 2. Because the fourth root of 16 is 2. Okay? So the fourth root of 16 is 2. So if I'm going to 2 raised to 4, that's 16. Okay? So that I can evaluate fourth root of 16 as 2. So 16 times 2, because we have 2, because 16 times 2 is 32. And what are we going to do next is this x raised to 9, we need to split off another x here, okay, in order for that to become uh, even, because we have an index that is even. Okay, so now I have x raised to 9. I'm going to rewrite it as x multiplied by x, okay, raised to n raised to 4. So what number of n would make this equation true? So this must be x raised to 2, x squared. Because x squared raised to 4 is x raised to 8 times x is x raised to 9. Okay? So that I'm going to rewrite this as x squared raised to 4. So the goal is we want to make sure that the exponent of our x is the same with the index so we can easily cancel it out. Okay? That's the goal. And then also, for our y raised to 5, this is an this is an odd number, so I'm going to split of 1y here. And then I'm going to have y raised to 4 here. So it's very simple. That's the formula. That is again the rule that we're going to use. Y raised to 4. Okay? And then for our last one is for our z raised to 12. So since this is an even number, I'm going to think of a number wherein if it is raised to 4, it will become raised to 12. So that number is 3. Z cubed times 4. Okay? So this would be Z cubed raised to 4. So again, I have transformed all of the exponents inside the radical sign to be equal with the index. So we have 4, the 4, we have 4 here, and then we have 4 and 4. And then we can now simplify. I'm going to get the fourth root of 16. I'm going to mix 2 with x and y. So multiplied by the fourth root of x squared raised to 4 multiplied by the fourth root of y raised to 4. I'm doing this first. All of those will have simplification. And then multiplied by the fourth root of z cubed raised to 4. Finally, multiplied by the fourth root of the 2 times x times y that we have split off a while ago. So we have fourth root of 2xy. So fourth root of 16 is 2. So this cancels out. So we have x squared. This cancels. Okay. So we have y. Okay. The fourth root of the y raised to 4 equals y because the fourth root of y raised to 4, if we rewrite it in exponential form, that's y raised to 4 all over 4, or y raised to 1, or simply y. So that's why we have y here. That's why we have y here. 4 cancels, so we have z cubed. Then we have fourth root of the 2xy. And this must be our answer for this particular radical problem. Okay, I know this is some very basic, but it's very much needed in the study of the higher mathematics. So let me give you or leave you with an exercise. That's the fifth root of x raised to 12, y raised to 4, z raised to 24. And the answer here should be, guys, should be x squared, z raised to 4, fifth root of x squared, y raised to 4, z raised to 4. Notice how all of the exponent in the final answer is less than the index. Okay. So that's an exercise to you guys. And I hope you find this video helpful. And if you are new to my channel, please don't forget to subscribe for more engineering tutorial videos and math tutorial videos. And I hope that I'll still be uploading, and I'll be continue uploading videos in college algebra. So again, guys, thank you so much for listening. Again, this is Engineer Abat. See you again on the next video.